Welcome to Lesson 8, Aircraft Structural Components. We will discuss the major structural components of aircraft as well as the three axes of rotation. It is not all-inclusive of everything you need to know on the subject. Further information on the topic can be found in FAA-H-8083-30, the Aviation Maintenance Technician's General Handbook in Chapter 3. The four main areas of the aircraft we will discuss in this lesson are the fuselage, the wings, the empennage, and the control surfaces. The fuselage is the main body of an aircraft to which the wing, tail surfaces, and engines are attached on an airplane. It usually contains the crew, passenger, and cargo areas. The wings are the part of the aircraft which produce lift to overcome the force of gravity. In a helicopter, the rotor serves this purpose. The empennage is the tail assembly of an airplane, usually serving as the attachment point for the rudder, elevators, and horizontal and vertical stabilizers. The primary flight controls of an aircraft are the ailerons, rudder, and the elevator. The three axes of an aircraft are the longitudinal, lateral, and vertical axis. The ailerons cause the airplane to roll about the longitudinal axis. The elevators cause the aircraft to pitch up or down about the lateral axis. And the rudder pedals cause the aircraft to yaw left or right about the vertical axis. Ailerons are small hinged sections on the outboard portion of a wing. Ailerons usually work in opposition. As the right aileron is deflected upward, the left is deflected downward, and vice versa. The ailerons cause the airplane to roll about its longitudinal axis. If we wanted to roll about the longitudinal axis, we would move the yoke or stick in the direction of desired roll. If we were to roll to the left, such an action would cause the left aileron to deflect upward and the right aileron to deflect downward. This would result in the left wing being deflected downward and the right wing being deflected upward, creating a component of lift acting to the left, causing the plane to begin turning to the left. The elevators cause the airplane to pitch about the lateral axis. If we were to pull back on the yoke or the stick, that would deflect the elevators upward, forcing the tail of the airplane down and the nose upward. If we were to push forward on the yoke or stick, that would deflect the elevators down, forcing the tail up and the nose of the aircraft down. The rudder causes the airplane to yaw about its vertical axis. If I wanted to cause the airplane to yaw to the left, I would step on the left rudder pedal, which would deflect the rudder to the left, forcing the tail of the aircraft to the right and the nose to the left. If I wanted the airplane to yaw to the right, I would step on the right rudder pedal, deflecting the right rudder to the right, forcing the tail to the left, and turning the nose of the airplane to the right. Flaps are hinged surfaces on the trailing edge of the wings of a fixed-wing aircraft. As flaps are extended, the stalling speed of the aircraft is reduced. Flaps are also used on the leading edge of the wings of some high-speed jet aircraft, where they may be called Kruger flaps. Flaps increase the camber of the wing airfoil, thus raising the lift coefficient. This increase in lift coefficient allows the aircraft to generate more lift at a lower speed. Therefore, extending the flaps will reduce the stalling speed of the aircraft. Extending the flaps also increases the drag coefficient of an aircraft. Therefore, for any given weight and airspeed, flaps increase the drag force.